Although the Australian Alps are dominated by a montane climate, they have no dry season and a mild summer. The Australian Alps bioregion contains a patch of true alpine climate. This area in the southwest of the bioregion presents the only example of alpine and subalpine climates in New South Wales, characterised by no dry season and a cool summer. In the Australian Alps, for every 1,000 metre rise in altitude, there is a 6.5 degrees Celsius drop in ambient air temperature in the troposphere. This is called the environmental lapse rate. It occurs because the atmosphere is not warmed directly by the sun, but by heat radiated from the sun's surface and distributed by conduction and convection. As altitude increases, the temperature falls because 1. There is a decrease in the water vapour, carbon dioxide and dust which absorb and retain heat. 2. There's a decrease in the land area available to radiate heat. And 3. Here is a decrease in density and pressure of air which reduces its ability to retain heat. Cold temperatures in the winter mean that precipitation falls as snow that then covers the higher altitudes for many months. The Australian Alps experience rain, hail, sleet, snow, frost, strong winds, low temperatures and frequent blizzards, especially during winter and spring. During summer, the occasional dry sunny day can see daytime temperatures rising above 30 degrees Celsius, but the nights are cool. Persistent snow cover over the winter months makes the Australian Alps an important region for skiing and snowboarding. A number of resorts have developed throughout the Alps, including Thredbo, Perisher, Mount Buller, and Falls Creek. These places experience both the coldest temperatures in Australia, but also some of the greatest visitor numbers. Mild mountain climates of mid-latitude biomes, such as the Australian Alps, support an important water storage function. The high precipitation and ability to hold water and regulate its discharge to rivers flowing out of the alpine environment and generate seepage downslope makes the Australian Alps an important water storage for the eastern coastal catchments and the Murray-Darling Basin. Precipitation occurs all year round, but it's greatest in winter and spring. During winter, much is held as snow and ice held back from the streams until it thaws in warmer weather. Stream flows are also boosted during early summer, ensuring water availability for most of the year. Transpiration, which is a major form of water loss in other areas of Australia, remains low all year in the Alps due to low daytime temperatures. Geomorphic processes of uplift and denudation are largely responsible for the formation of the Australian Alps and its various lithospheric features. The process of orogenesis involves the faulting and folding of the Earth's crust to form mountains. The materials which constitute the lithosphere of the Australian Alps were deposited millions of years ago. The highland area was once underwater, where coral reefs provided the region's limestone base. Silt, sand and ash and lava resulting from volcanic activity were then laid upon the coral reefs. 160 million years ago, the ancient continent of 160 million years ago, Australia was part of the ancient supercontinent of Gondwana, and Kosciuszko was part of a low plain. Gondwana began to stretch apart from lines of weakness, and the Earth's crust became thinner and thinner. Hot magma then rose to the surface, heating the crust and expanding upwards to form a plateau. 100 million years ago, the countries of Gondwana split. Large faults began to form along the uplifted plateau, splitting it in the middle and forming a rift valley. 80 million years ago, the sea invaded the expanding rift, and the western side of the plateau formed Australia's eastern coastline. Following a period of uplift, the Alps underwent extensive denudation, weathering and erosion, to form the undulating plateau seen today. So denudation encompasses all processes that cause the wearing away of the Earth's surface by moving water, ice, wind and waves, leading to a reduction in elevation and relief of landforms and landscapes. Chemical weathering involves weak acids reacting with the minerals in rocks, leading to their disintegration.
Mechanical weathering involves the physical disintegration of exposed rock without any change in their chemical composition. Fluvial erosion involves rivers and streams eroding less resistant rocks to form deep, wide valleys and narrow gorges. An example of this is Threadbow Valley. Aeolian erosion results from wind removing many of the layers of sedimentary rock, exposing harder rocks and rounding the surface of other rocks. Glacial erosion results in features such as cirque lakes and moraines through plucking and abrasion. Examples of this include Club Lake and Blue Lake, which are examples of cirques, and Lake Albina and Lake Kudapatamba as examples of moraines. Periglacial erosion results from seasonal freezing and thawing of snow in areas of permafrost adjacent to a glacier or ice sheet. Types of periglacial erosion include mass movement, needle ice, ice wedges, and novation. Soil formation. Low temperatures associated with high altitude slow down the chemical weathering of various types of bedrock, slowing the formation of soil. Humus decomposes slowly in the cold conditions of the Alpine zone, leading to a low nutrient content of soils at high elevation and therefore slow growth of vegetation. There are a large number of soil types within the Alpine zone, including humus, loams, peats, and lithosols. Soil type is determined by the type of rock beneath, its gradient, and exposure to weather. Hydrologic processes. The Alpine zone is home to a number of significant water flows and storages, including the headwaters of the Snowy and Murray rivers and natural reservoirs such as Lake Kudapatamba. Flows within the Alpine zone result from low levels of evaporation and transpiration, resulting from low temperatures experienced in the Alpine zone, high precipitation in the form of rain and snow, and water derived from snow melt. The ecosystem also possesses a high water holding capacity due to the prevalence of sphagnum bogs capable of retaining quantities of up to 20 times their own weight, quantities of water up to 20 times their own weight, low temperatures which result in water being seasonally stored as snow, and high levels of humus, dead plant and animal matter, which enable soils and peats to retain and release large quantities of water, given the high levels of precipitation.
Invasion in the Kosciuszko Alpine zone occurs due to exotic animal and plant species, including feral horses, sambar deer, foxes, cats, and pigs, as well as plant species such as orange hawkweed and oxeye daisies. Introduced animals can place additional pressure on species living in the Alpine zone as they prey on native species such as mountain pygmy possums, and also reduce the amount of native habitat and food sources. Feral horses were identified as an increasing threat in the 2016 review of the Horse Management Plan. They cause the trampling of vegetation such as the fragile sphagnum bogs. Due to climate change, introduced species will infringe more vigorously in alpine areas as they are no longer excluded by low temperatures and snow cover. The alpine ecosystems are modified majorly by human activities, including tourism, historical grazing, and construction of infrastructure such as the old road to the summit of Kosciuszko. Grazing dramatically altered the landscape, causing large sheet erosion, which continues today. Natural events can also alter the alpine ecosystem, such as bushfires. The fires in 2003 caused a dramatic alteration in the landscape, removing a large amount of the vegetation, as you can see there. 1.73 million hectares were burnt by the fires, and that moved a lot of habitat, which is still recovering in modern times. Climate change will modify the composition of the alpine ecosystems as species both introduced and native move uphill and infringe on the alpine zone, and species are lost in the alpine ecosystem due to the exclusion of their bioclimatic ranges or habitat. Variation in successional stages of vegetation is altered by catastrophic natural disturbance such as bushfires, which can eradicate vegetation altogether or isolate it in very small areas. Additionally, introduced species can damage vegetation, which takes long periods to recover and replace a variety of species with just one introduced species. Alpine zone of Kosciuszko National Park is combined to a small area estimated to be 100 square kilometres in total, which will continue to decrease due to climate change and rising temperatures. Due to its small extent, ecosystem is not overly resilient and able to recuperate from threats and changes. The Alpine zone has low levels of elasticity, as these ecosystems are highly vulnerable and take very long periods to recover from changes due to small rates because of very cold temperatures. The zone has high levels of biodiversity, but the species are highly vulnerable to temperature ranges, and a number of the species in Kosciuszko Alpine zone are endemic. 21 plant species are endemic to the zone, meaning they are found nowhere else in Australia or the world.